Hello guys, welcome to the clinic. I am your prof, and today I'll be taking you through the concept of ordinary differential equation. Now, some of you guys have heard about the concept of ODE, ordinary differential equation, but in this class, I'll be telling you what exactly is an ODE, how do you solve an ODE, and what are the simple methods you can use when attempting an ordinary differential equation questions. So let me start by explaining what exactly is an ODE. Now when we say, look at the word, ordinary differential equation, the first thing you need to know is that anything called an ODE is an equation. But that prompts the question that, which kind of equation? Now we know that anything called an ODE is an equation from the word ordinary differential equation. But it is not just any kind of equation. It is an equation that contains three things, three vital things you must observe, three vital things when you're talking about an ODE. And the very first thing is, you must find that it contains an independent variable, that's number one. Two, it must contain a dependent variable. And three, it must contain their derivative. That means the derivative of y with respect to x, in a case where you are using x and y. Now let me show you better. If you have this, suppose you have an equation x plus 3y equals 7. I cannot call this an ODE. And the reason why I cannot call this an ordinary differential equation is because, yes, truly, it contains an independent variable, x, it contains a dependent variable, y, but it does not have any derivative here. So because of that, I cannot say this is an ordinary differential equation. But perhaps, if you have a description of this nature, if you have x plus 3y equals 6 the y dx, this expression can be called an ordinary differential equation. And the reason why we can call this an ordinary differential equation is because it contains all those three entities. Number one, it has an independent variable, x. Number two, it has a dependent variable, y. And number three, it has the derivative of y with respect to x. Now the question I expect you, or the question you would like to ask is this just something like this? No, it's not just something like this. But in any case, where you have a situation that has, or an equation that has the independent variable, the dependent variable, and any derivative. Let me give you another example. If you have the square y dx squared minus 6y equals 7. You might even ask, is this an ODE? Yes, it's an ODE. The most important thing every ODE must have is the derivative. So if you look at it, we have the derivative, which is the square y, the x squared, a second derivative. That means the y, the x, that's the first derivative. The square y, the x squared, that is the second. So this one contains the second derivative. Now, you have the dependent variable y, but you will be like, where is the independent variable x? Yes, the independent variable x is not here because its coefficient is 0. But you still are, like I said, the most important thing every ODE must contain is the derivative. So this is still an ODE. Now, another one to say, the cube y, the x cube equals 9. Someone could ask you, is this also an ODE? Yes, it's an ODE. Just because I already told you that. In every ODE, yes, you must have three things. The independent variable, the dependent variable, and their derivative. But at the same time, the most important thing is the derivative. Because even when you don't add these two, the dependent and the independent variable, if you don't have it there, at the same time, you can still have an ODE. The only reason is, look at this. I can rewrite this as the cube y, the x cube, plus 0x plus 0y equals 9. This which you have here is the same thing as everything I have here. The only difference is because I have been able to show to you that the coefficient of x and the coefficient of y are 0. I hope you're getting me now. And that brings us to the derivation. Here we said, an ordinary differential equation is any equation that contains the following. Number one, like I explained, x, which is representing independent variable. Because at times, if I go on to give you this, if I give you the p dq minus q equals 3p, some of us will be like, oh, why are we not having x? Why are we not having y? So it doesn't have to be x and y alone. That's why I'm telling you that all you need to see is that it contains independent variable. In this case now, you will have it that the independent variable is q and the dependent variable is p. So let's move on. An ordinary differential equation is any equation that contains the following. Number one, an independent variable. In this case, we are using x. And all through this class, we'll be representing the independent variable as x. And the dependent variable y. And their derivative. The derivative could be the first derivative, the second derivative, the third derivative. So when you have any equation of that nature, what we call them is an ordinary differential equation. And like I've given examples while I was explaining the definition, I'd still like to add here that you can have the y with respect to the x minus 3y equals x. This is an ordinary differential equation. And at the same time, you can have the square y, the x squared, plus 2dy dx plus y equals 0. This is also an ordinary differential equation. So I believe, I want to say, with the explanation above, you can easily identify what an ODE is. But it does not stop there. That moves us to the next concept, which is how to identify the order and degree of a differential equation. Now we know that, okay, you understand what a differential equation looks like. You can tell us what an ODE is. But the next question you should be asking yourself is, okay, when I see an ODE, and I'm asked that, what is the order of that ordinary differential equation? How do I identify that? Because now I can identify ODE. So that is where we're moving to. But I want to say that there is no way you can, these two relate. You cannot identify the degree of an ordinary differential equation without a proper understanding of what the order is. Now let me break it to you. With these three examples. Number one, if you have the y with respect to the x plus 3y equals 7x, you will tell me this is an ODE. Number two, if I have 6 the square y, the x squared, everything here raised to power 4 equals 8 the y dx minus 7y. And number 3, let's say we have the cube y, the x cube, plus raised to power 4, plus the square y, the x squared, raised to power 7, minus 6y equals 8. Now, the first case is, all these three, they are ordinary differential equations. We all know that. Now, the question is, how do we identify the order? Or exactly, let's say, what is an order of a differential equation? Let me just say, the order to any differential equation, if you are given any differential equation now, and you are asked to find the order to that differential equation, the order to any differential equation is the highest derivative. The highest derivative present in that differential equation. If you have the y dx, that means you have differentiated once. If you have the square y, the x squared, this means you have differentiated twice. And if you have the cube y, the x cube, it means you have differentiated 3 times. So if you are given any differential equation now, the first thing you need to look at is, what is the highest derivative present in that differential equation? Now, if we look at this now, we'll see that the only derivative we have here is the y dx. And the y dx, it shows that we have only differentiated once. By that, I can tell you that the order here, in this first question, the order of this differential equation is y. So this differential equation is a differential equation of order y. I think we are clear with that. Now, we'll go to the second one. In this case, we have the y dx that tells us we have differentiated once. And in this case, we have the square y, the x squared. Ignore the power for now. The square y, the x squared. The square y, the x squared tells us we have differentiated this equation, we have differentiated the expression of y twice. So this is telling us the derivative of y with respect to x one time. This is telling us twice. So the highest derivative here is this, which is telling us we have differentiated twice. In that case, the order of this differential equation is 2. Now, the third one, if we go to this now, without wasting much of our time, if you are asked, what is the order of this differential equation? All you need to do is look into this differential equation and check what is the highest derivative. This is the square y, the x squared, and this is the cube y, the s cubed. You can easily see the order equals 3. But please don't make this mistake. It is not a must that the order must come first. No, we can arrange it in any order. What matters is you look into your differential equation, check for the highest derivative, and pick it out. I think we are clear. So like I said in summary, the order of any differential equation is the highest derivative you can find in that differential equation. That now leads us to what is a degree. Because I said the other time that without a proper understanding of what the order is, you cannot get the degree of that differential equation. Now, if you are asked to find the degree of a differential equation, the degree to any differential equation is the index, is the power. Is the power of the order in that differential equation. Let me say it again. The degree of any differential equation is the power, is the index of the order of that differential equation. This is what I'm saying. In this differential equation, this is where we have the order, and this is of order 1. But if I check the index, this, the y dx, is done in raised to power 1. So I can easily see that the y dx here, which is the order, is only done once. So the degree here is degree 1, which means the order tells you the degree. Now, if you come to this place now, this differential equation is a differential equation of order 2 because of this. But the index on this order is 4. So it's a differential equation of order 2 degree 4. And if you come to this one now, in this case, you still come, the order here is order 3. And the index on this order is 4. So it's a differential equation of order 3 degree 4. So if you look at this now, you have been able, in this concept now you can identify what a differential equation is. You can tell us what the degree of a differential equation is, and likewise the order of a differential equation.